Good day, my name is Gabriel Gazaya Lim, ID 122, and I will be teaching ENGMEC1 Quiz 1. For our last question, we are presented with bar AB having a length of 10 mm. For our last question, we are presented with bar AB having a length of 10 meters. The negligible weight rests in a horizontal position on the smooth planes. So we're asked to find the distance x at which load 10 kilonewtons should be placed from point B to keep the bar horizontal. So it's going to be this distance. Now, this may look a bit challenging at first, but what we can use here is the force polygon, the one where all the forces, when put together, they would make a polygon, or most times a triangle. So we can start drawing out the forces here. So this one over here has an angle 45, while this one has an angle of 60. And because if you look at it, we do it like that. This is 30, this is 60. Then since it's perpendicular to it, it will be like that. A 90 degrees, so this will be 30. And the one over here is 60. So just a bit of analysis on that part. Just be careful with it. Now we can put it all together. Let's call this reaction A because it's around point A in the reaction B. We have reaction A, and then we have this one going down, P, which is 40 kilonewtons going down. Then say that's P 40 kN, and then we have T, which is also 10 kN, or T 10 kN. And then we have RB. So from there, we can determine the sides. So let's just put some angles here. This is 60, then this must be 30 degrees. If this is 45, this should also be 45. And to get the last one, just do 180 minus 30 and 45. You're gonna get 105. And then just perform law of sines for this one. So what we can do is law of sines, angle, and opposite side. Let's say we're finding RA. So RA over sine 45 is equal to 40 plus 10, which is this side, of over sine 105. So let's calculate that. So RA is going to be 36.60 kilonewtons. Now we can also find RB, but we have to look at the question again. It's asking for the distance at X at which load T can be placed. Now, if we think about it, how are we going to find the distance? The only thing that would give us the distance, it's not going to be sum of forces in the X, not sum of forces in the Y, but sum of moments around a certain point, which we can do around B. So there isn't a need to do RB since we already have RA. So let's go to the moment part already. So if we do moment around B, make sure to indicate the orientation. All we need to do is just find the distances between them. So this will be equal to 0 because it says it rests. It doesn't say it's moving. So if we're going to look first at the 40 kilonewtons, this is the point over here, B. We could see it's going counterclockwise. So that's negative 40. And since this is 3 meters, and the entire bar is 10 meters, the rest from here to here, it's going to be 7 meters. Just add in, subtract. 7. Now, since we have RA, we can just get the y component of it because the x part is acting on the point B, so that's going to cancel out. It's not going to have any effect on our point. So to get the y component, we have to use sign. So RA is 36.60, and it's going to be a positive one because it is going clockwise. And then we have to make it sine 60. Multiply, never forget that, multiply by 10. Okay, and then the last one, we have t, which is also negative because it is counterclockwise. It's going to be negative 10 kn multiplied by x. All right, so since it's equal to 0, we can find x immediately. So if we move this one to the other side, it's going to look like this. 10x is equal to negative 40 times 7 plus 36.60 sine 60. All right. So let's start calculating. So after we calculate, we're going to get x is equal to 3.6965 or around 3.70 meters. And there's our answer. Our answer, distance x, is equal to 3.70 meters. So for this example, we had to use our knowledge in the sum of moments and also a bit of the force triangle, the force polygon rather, and also some sine law as well. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flash on your screens. Once again, this is Gabriel Lim from Syntax, paving your way to excellence.